Hey, sorry to be giving you another video. I know I said I wouldn't be doing so many videos when I came back in person, but then 3 out of 4 people in my family got COVID, so I'm going to be home this week. But I wanted to give you a quick video to introduce a topic from a couple of actually chapter before what we've been working on to cover a topic called function composition, which is something I hoped we were going to do last semester, but we didn't get to. And really, it's a fancy name for something that you've already been doing. So I don't want to take too long with this. I want to give you some time to practice with it. I actually found a website with like a cool interactive thing that'll help you practice it. But basically, the idea of function composition is something that you've already done. So I'm going to show you a worksheet that you probably remember from last semester if you were in my last semester. If not, you've probably done something like this, right? So this is a worksheet where y'all were just practicing evaluating functions. So when you started out, you had these function definitions, and then we're asked to find the function value at a certain value. But then as you kept going, you started saying, okay, well, here's h of x equals 4x minus 2. Find h of x plus 2. So what did you have to do here? Instead of just plugging in a number, you're actually plugging in this expression with x. So h of x plus 2 means this is your definition of the function h. Everywhere you see the x, you plug in x plus 2, and you get 4 times x plus 2 minus 2. And then you can simplify that and say that's 4x plus 8 minus 2, and you end up with 4x plus 6. So this right here is when you take a function and you plug another function into it, right? So you might have something like that. You might have this here, f of n is n squared minus 2n. If you want to find f of n squared, everywhere that you see n, plug in an n squared. So you're squaring your input here. If you put your input as squared, you square the whole thing, minus 2 times n squared. So right, everywhere you had an n in the original function, you plug in n squared, and then you simplify, and you get n to the 4th minus 2n squared. All right, so this actually is function composition. The idea of composing a function is just plugging a function in, right? So your input for your function is another function. In this case, that, right, we're looking at x plus 2 is a function of x, but we're plugging it into our function h. So we're going to give this slightly more formal definition and a more formal notation, which is really going to be the part that you're going to have to practice. So the definition, which you can find on page 294, section 2.6 in your book. So the composition of function f and g. Is denoted by, so we write this as a new symbol, f, and then a little circle, g, and is defined f circle g, or f composed with g of x, is saying you take your function f, the first one, and you input the function g, your second one. And then as part of that definition, we also want to look at the domain. The domain of this composition, putting these two functions together. All x such that first, x is in the domain of g. right? Since our input, the first thing we have to do is evaluate g. For something to be in the domain of this function together, it has to be in the function of the first one. First, meaning the inside one. And then second, g of x has to be in the domain of f. Right? This makes sense because g has to be able to be evaluated with x, right? So that's in the domain of g. And then whatever you get out of g is going into f. So it has to be in the domain of f. Oh, sorry, technical difficulties. So let's do a couple of practice ones so you can see how this works. So for example, let's define f of x is 3x minus 4. G of x is x squared minus 2x plus 6. So we can compose these functions. We can put them together two different ways. We can do f which is f of g of x, where g of x becomes the input into f. So what does that look like? That looks like f of g. Right now we're just we're not a single number input. So what we get out of this is going to be another function of x. So f composed of g of x is f of g of x. We plug g of x in as the input for f. F says take your input and multiply it by 3. Oh, no. And then subtract 4, right? So f of x says take whatever you put in, multiply it by 3, then subtract 4. If we're inputting this function g, that's what it looks like. Then we can simplify and we get 3x squared minus 6x plus 18 minus 4. So f of g of x makes a new function where we plug the function g into f, we do what f says, and we get this out. We also can compose it the other way. We could take g of f of x, and we'll see that it'll give us something different. It matters in what order you do it. So g says take your input, square it, multiply it by 2 and subtract, add 6. So that's going to be g of 3x minus 4. Let's take this 3x minus 4, square it, minus 2 times 3x minus 4, and then add 6. Right? So here in our original, everywhere there was an x, we plug in 3x minus 4. And then we simplify. I'm going to do this. Right, we're going to, in order to 3x minus 4 squared is 3x minus 4. Right, so we have to expand that. So we're going to do our little FOIL, do our 4 multiplications, and we get 9x squared, 3x times minus 4 is going to give us minus 24x plus 16. That's just FOILing it out. You can use the box method if you prefer. And then here happens squared minus 30x plus 16. So we can take these two functions, 3x minus 4, x squared minus 2x plus 6, and compose them two different ways. We can do G first and then F. We can do F first and then G, and we get two completely different functions. And then the last note, and then I want to show you this interactive tool to help you, is talking about the domain. So here, let's just take a quick notice. Both F and G are polynomials. We know that the domain of a polynomial is all real numbers. So when we look at X as in the domain of G, it's going to be all real numbers, and then any output of G is going to be a real number, which will be in the domain of F. So we don't really have to worry about if you compose a polynomial with a polynomial, the domain is still going to be all real numbers because there's nothing you have to throw out. It's when you get into functions that have slightly more complicated domains that you have to kind of think about it. So let's do an example where we're thinking about the domain. If we have f of x is the square root of x and g of x is 1 over x, then these are both functions that have a slightly more limited domain. We have some restrictions. The domain of f. What's our rule here? We can't take the square root of a negative number. So the domain of f is going to be all x's that are greater than or equal to 0. The square root of 0 is just 0. It's fine. Anything bigger than 0 is fine. We can write that as an interval. Interval that everyone loves. X is going to be x. 0 is our lowest number that x could equal. So we can say that that's going to be a closed bracket on 0 to infinity, to as big as you want. And then what about G? The domain of G, the rule that we have is be dividing by 0. So it's all going to be all x that are not equal to 0, right? Or you can say all. So we want to think about if we compose these, if we say f of g of x, right, then that's going to equal f inside. So f of 1 over x. F says over x. So the domain here is going to be all x that are in the domain of G. So that's everything except 0. Okay, so x can't equal 0. And then it has to be everything so that the output of 1 over x is in the domain of f. So 1 over x has to be positive or non-negative, right? 1 over x will never equal 0. There's nothing you can plug in, because if you plug in 0, it's not defined. So everything's either going to be positive or negative. So it can't be 0, and it has to be positive. So x is going to be greater than 0. So we now are looking at the domain from 0 to infinity, where 0 is not included because you can't define that. So that's how the domain for the composition of functions that have restricted functions is going to look. So I found this website. Let me share. Oh. I think is helpful. It's called almostfun.org, and it has a lesson on function composition. I think that the thing that's cool about this is it's interactive, so it'll give you some examples. So I like this idea of, right, you can think of these functions in a more real life example. Would be if you get 2 coupons, 2 discounts on something, what's going to give you a better deal, taking the percentage and then the $10 off, or the $10 off and the percentage. And you can see, and it shows you the different ways that that goes. Time to read that on your phone. And then it actually has a calculator. So if you want to figure out how this works, you can put in your function. So if f of x is x plus 2 and g of x is x divided by 10, you can then say, what do you want to try that on. Let's see what's g of f of 6. So first we do, I said f of x is x plus 2. So it'll show you x plus 2, f of 6. So 6 plus 2 is 8. Next step, we take the 8, we put it into g of x, which is x over 10, and it'll actually calculate it for you, right? And then you can say you want to do f of g of x and see how that goes. It does g of x first, gives you 3/5, and then adds 2. So if you're trying to figure out how to do this, it can show you and actually walk you through how it gets the answer. So inside and then outside. Right, so it shows you first with variables, and then with numerical input. So trying variable input. So this is where you're going to get another function out as your end result. And then this is going to be where you're going to get your an answer, like a numerical answer. And it also shows you how to do this based on graphs, which is great. So I'm going to stop talking and I'm going to direct you towards Canvas, where an assignment of how to do some practice problems on this is posted.